Hello, grade 9. This video will be attached to the second worksheet that I just posted on Google Classroom. This worksheet is a revision for the linear function transformation, or the transforming the linear functions. In this worksheet, you'll find how to make the slope-intercept form, how to change into the slope-intercept form and the general form, or the y-intercept and the slope form, and then how to graph it. Okay. Then in the third page, you'll see three different examples on how to graph these linear functions, and then we'll be talking about the transformation. So first, let's just have a quick revision on how to graph a linear function that is in the y-intercept form, the y-intercept and slope form. Okay, I'm going to use this paper to make it easier. Okay, let's have an example of let's say y is equal to 3 over 2x minus 2. Now first we need to identify what is the slope and what is the y-intercept in this equation or in this function. In here we have the slope, which is 3 over 2, which is always the coefficient of x, and the y-intercept, which is the constant number next to the x right here. That is always after you make the equation on this form, on the slope y-intercept form, which is y equals a number multiplied by x plus or minus a constant. Okay, now first let's just write this down. The slope is 3 over 2, where the y-intercept is negative 2. Okay, now let's graph this. First, we start with the y-intercept, okay? What is the y-intercept here? Is negative 2. So we go 2 steps down in the y-axis. This is the y-axis. This is 1, 2, 3, 4. And then we have negative 1, negative 2, negative 3, negative 4. We go to negative 2. That's negative 1. That is negative 2. And we make a point. This is the first point. Now, to graph a line, we need at least 2 points. At least. Okay? To find the second point, we just check the slope. What is the slope? It's 3 over 2. That's called rise over run, which means the values or the steps we move on the y over the steps we move on the x. That's what the numerator and denominator works for, or stands for, sorry. So the 3 here is the steps that we're going to move on the y-axis, where the 2 is the steps that we're going to move on the x-axis. Let's see how this works. Now we go to the we always start from our y-intercept. Okay, many of you make this mistake. You guys start from the origin, which is from the 0, 0 here point. You don't start from here. You always start from the y-intercept, which is in this case negative 2. So we start from here. We see how many steps are we moving on the y-axis? 3 steps, positive 3 steps. So we go up 3 steps. 1, 2, 3 steps. So we stop here, which is on the 1 coordinate of the y-axis. Then we have on the x-axis we're moving 2. So where we stopped at here, we move 2 steps to the right. So it is 1, 2 steps. We are right here. So do you see where you just stopped here? Now this is our second point. If you connect these 2 points together, you will get your line. Okay, so this is how to graph a linear equation with the slope y-intercept form. We already talked about this before. This is just a quick revision for it. If you had any further questions regarding the examples in the worksheet, just let me know. Now let's talk about transforming these equations or these functions. Let's start with, okay, sorry. Let's start with this example. Let's say we have an original function that is f of x is equal to 2x minus 1. This is the original function, and this function was translated up 5 steps. Okay, so we have 5 steps up. That's written in the worksheet in front of you. Okay, now when the line is shifted up or down, that means it's moving on the y-axis like this. Here, this is our line right here, represented by the pen. If it was shifted up or down, that means it's moving on the y-axis. So the number of steps that we're going to add or subtract will be from the y-axis, which means it's going to be from the y-intercept here. Okay, but if this line, which is represented by the pen here, is moving to the right or to the left, that means what we're shifting here is the number on the x-axis, which will be the x itself. Here we'll see how this works. Now, this is our original function, and it was shifted 5 steps up. Now, how do we change this? How do we translate this? Let's call the new function g of x. This is just an example. Okay, we call the new function here g of x. Now, g of x is equal to, nothing changed on the x because we already said it's just 5 steps up, which means just on the y-axis. Okay, so here we're going to write 2x, which is still the same, it doesn't change. What changed here is the constant. Now the constant, the original one, is -1. The steps moved up, which means we're going to add. So we're going to add 5 to this equation. So it becomes g of x equals 2x, okay, 5 minus 1, which is, so here now I have -1, plus 5, which is plus 4. So if we graph this line and then we graph this line, we will see the difference. We'll see that it was shifted up 5 steps. Let's see how this was actually shifted. Okay. Okay. These are our coordinates, x and y coordinates. Okay, our line, our original line is f of x equals 2x minus 1, which means the y-intercept is -1, which is right here, and then the slope is 2, which means we're going to move, it's 2. So when the slope is 2, that means, let's just write it here, the first slope is equal to 2, which means it's 2 over 1. So the rise over run is 2 over 1. So we're going to go up 2 steps. So it's 1, 2, and then 1 step to the right, which is right here. And then we stop, and then we make a point, and this is our original line, which is called f of x. Now let's see how this was translated. When we did it without graphing, when we did it algebraically right here, we got a new function that is 2x plus 4. Let's see if we graph the 2x plus 4, what do we get? Okay, it's 2x, okay, g of x right here. G of x is equal to 2x plus 4. That's the new one that we're going to just graph and see the difference. Let's make it in another color. Okay, let's just graph it first and then we'll talk about this. Okay, first let's see what is the y-intercept. Here it is 4. So on the y-axis we look at the 4, number 4, which is 1, 2, 3, 4. Here, right here, this is our first point. Then we have the slope, which is also 2, so it's 2 over 1. So from here, from our y-intercept, we're going to move 2 steps up. So it is 1, 2, and then 1 step to the right, which is right here. So this is our new line. Here, we just connect them, and we can extend the line to infinity. So this is our new line, which is called g of x. Okay, this is g. Sorry, this is g of x. Okay. Okay. Now, do you see this? This is our line. Okay. Now, let's see how many steps it was moved. This is the original one, okay? Look at the steps right here. Look at the y-axis. It was moved 1 step, 2 steps, 3 steps. Again, -1, right? And here 1, 2, 3, 4. So we have 1, 2, 3, 4, and 5. So we have 5 steps up. That's the meaning of translating on the y-axis 5 steps up. Okay, this is how it's represented graphically. Okay, now let's just have another example for shifting an equation or shifting a function on the x-axis. Okay, the second example that you have here is f of x. Oh, it's the same. Yeah, it's the same function, but we're just going to shift on the x. We're going to shift to the left 5 steps. Okay, we'll be shifting it to the left 5 steps. So let's just go back to our. Yeah, it's the same line right here. This is the line. This is our original line. Our original line, which is f of x, is equal to. I'm going to write it here. Let's just have our paper next to us so we can use it. Here. Now, right here, we have the original equation, or the original function, sorry, which is right here. F of x is equal to 2x minus 1, which is right here. Okay, we already show how g of x looks like. Let's call the new equation. Let's call the new equation right here. Let's call it h. Let's call it h of x. Now, h of x, which represents how this function is translated 5 steps to the left. Okay, was translated 5 steps to the left, which means instead of having just f of x, we'll be translating the input. So we're adding or subtracting to the input itself. Since it's going to the left, we're going to add instead of subtract. On the x-axis, it works the other way around. When we move to the left, we add. When we move to the right, we subtract. So here we're moving to the left 5 steps again. So we'll be having 2 instead of x here, we'll be putting x minus 5, plus 5, because we said to the left, okay, minus 1. Okay, clear? Now let's do this. Let's just, let's solve this, and let's just put it again into the slope intercept form. So it becomes h of x equals, we're going to multiply the 2 by these two elements inside, or the terms inside the bracket, so it becomes 2x plus 10. Minus 1 is still the same because it's not multiplied by anything in here. Okay, now we have the 10 minus 1, which is 9. So our new equation here, our new function h of x, is equal to 2x plus 9. Now let's graph this on the same coordinate plane and see what's happening here. Now here we already have the y-intercept, which is 9. So let's do this. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the new y-intercept. And then we have a slope, which is 2. So if the slope is 2, it's the same thing. So what we're having is 1, 2, up, and 1 to the right, like we did before. Now let's just connect these points and extend it until it just crosses the x-axis. I'm not very accurate here. So it's 1, 2, 3, 4, 5. It's supposed to be like this. Okay, this is incorrect. Let's just highlight it to be clear. This is h of x. Okay, right here, the pink line right here is h of x. Now let's see this. If this is our original line, let's see how many steps it will translate to the left. So it was translated, look, right here, because it is 2 and 1. So it is translated like this. So we have 1, 2, 3, 4, 5. It's going to be a bit closer, like to the 5, but between the 4 and 5, because this is, if it was very accurate, this is how you'll get it. So we just using graphs just makes it clear for us how it was translated. So please just check all these on the worksheet. It's already solved, and these graphs are very accurate on the worksheet. Also, we have the last case, which is multiplying by the output, which we already mentioned before, and we had a video for that, which is the slope. When we have the slope stretched, or we multiply by the slope. So for example, if we said that we want twice the slope, so we're going to multiply it by 2. It's also included in the worksheet. At the end, then we have a table. This table has 4 things, okay? Translating up and down, C units. C units means the number of units, just we called it C as a constant. And then we have translating to the left and to the right, C units again. And then we have stretching C times further from the x-axis, and then we have the stretch closer to the y-axis, which means if the number or the coefficient multiplied, or the constant or the factor multiplied by the slope is greater or less than 1. Then at the end you will find 2 or 3 papers full of examples. Okay, practice on them for the finals. They'll be very helpful. If you have any questions, just contact me, please. Have a good day.